Hi students, welcome to Sunil's tutorial. I am Sunil Mirwani and today we will be doing the numericals of some basic concepts. Please take down. Calculate the average atomic mass. Calculate the average atomic mass of argon. Calculate the average atomic mass of argon. Take on the data, guys. This is the data. Guys, no talking please. Now, let's see this. The average atomic mass. Average atomic mass. Now, how do I get the average atomic mass? The average atomic mass is nothing but the isotropic mass multiplied by its abundance. The average atomic mass is the isotropic mass multiplied by its abundance. So average atomic mass will be 35.96755 into 0.337 plus 35.96272 into 0.063 plus 35.9624 into 99.6, right? Divided by, add these three, 0.337 plus 0.063 plus 99.6, right? When you solve this, you will get your average atomic mass. How do you get it, guys? Isotropic mass multiplied by the abundance, isotropic mass multiplied by abundance, isotropic mass multiplied by abundance, right? Divided by the sum of abundance. When you solve this, you should get this answer as 39.948 grams per mole, right? Take on next one, please. I'm going to solve the sum partially, you can complete the sums later. Take on next one please. Boron occurs in nature. Boron occurs in nature in the form of two isotopes. In the form of two isotopes having atomic mass 10 and 11. What is the percentage abundance of the two isotopes? What is the percentage abundance of the two isotopes if the average atomic mass number is 10.8? If the average atomic mass number is 10.8. Now they've given you that there are two isotopes, one has atomic mass 10 and the other has atomic mass 11. Let us assume, guys, that the abundance of one is X. Now we know that abundance is always in the form of percentage. That means the total of this has to be 100. If one is X, then the other has to be 100 minus X. If one is X, the other has to be 100 minus X. Average atomic mass number, mass number is given by the formula average atomic mass number. Guys, average atomic mass number is given by the formula for atomic mass into abundance plus atomic mass into abundance. So this is going to be 10 into X plus 11 into 100 minus x divided by 100. average atomic mass is given to you as 10.8, so I can say 10.8 is 10x plus 1100 minus 11x upon 100. After this, you should be able to solve this and get the answer. I'll leave the answer for you all to solve. The answer for this should come to 20% and 80%. Answer should be 0.2 and 0.8. Fine, do we get this thing clear? Next, take down next one please. Calculate the number of moles. Calculate the number of moles and molecules of ammonia. Calculate the number of moles and molecules of ammonia present in 5.6 decimeter cube of its volume. Present in 5.6 decimeter cube of its volume. Present in 5.6 decimeter cube of its volume. Now we know, guys, that 1 mole of any substance, guys, you're supposed to know this by heart, 1 mole of any substance occupies 22.4 decimeter cube. In fact, we've done the derivation of this in the theory. 1 mole of any substance occupies 22.4 decimeter cube. Now they are saying that ammonia is occupying 5.6 decimeter cube. Ammonia is occupying a space of 5.6 decimeter cube. They are asking you how many moles will be present. So X will be nothing but 5.6 divided by 22.4, right? When you divide this, you will get 0.25 moles. So the first part of the question was calculate the number of moles. Now we know that if I use Avogadro's number, 1 mole of any substance has 6.022 or 6.023 into 10 raised to 23 molecules. One mole of any substance has 6.022 into 10 raised to 23 molecules. We have 0.25 moles of ammonia. So how many molecules will it have? X will be nothing but 0.25 into 6.022 into 10 raised to 23 molecules. When you multiply this, this will give you 1.505 into 10 raised to 23 molecules. So I've solved the sum completely. There are 0.25 moles of ammonia and there are 1.505 into 10 raised to 23 molecules of ammonia. Take on next one please. .9 grams of ammonia. 3.9 grams of ammonia at STP. STP stands for standard temperature and pressure. 3.9 grams of ammonia at STP occupies 4.48 decimeter cube. 4.48 decimeter cube. Calculate the molar mass of ammonia. Calculate the molar mass of ammonia. Calculate the molar mass of ammonia. Now see, what have they given you in the sum? The sum says that 3.49 grams of ammonia occupies 4.48 decimeter cube. Okay. Now, let us assume that 1 mole, we know that 1 mole of a gas occupies 22.4 decimeter cube. So let us assume that X is the molar mass. When they said that find the molar mass, means they have asked you to find the number of moles. So let us assume that x grams of ammonia occupies 22.4 decimeter cube, where x is nothing but it is the molar mass of ammonia, where x is molar mass of ammonia in grams. So when you solve this, you will get the value of x. You can get the value of x as 22.4 into 3.4 divided by 4.48. This can be written as x is equal to 22.4 into 3.4 upon 4.48. So you will come to know the number of moles. When you solve this, you will get this as 17.45 grams per mole. So the molar mass of ammonia is 17.45 grams per mole. Fine. Take down the next sum, please. Take down the next sum, please. Calculate the mass of potassium chlorate. Calculate the mass of potassium chlorate. Calculate the mass of potassium chlorate required to liberate. Calculate the mass of potassium chlorate required to liberate 6.72 decimeter cube. Required to liberate 6.72 decimeter cube of oxygen at STP if the molar mass of potassium chlorate is 112.5 grams per mole. If the molar mass of potassium chlorate is 112.5 grams per mole. Now guys, what is the molecular formula of potassium chlorate? Molecular formula of potassium chlorate is nothing but KClO3. Now they are saying that calculate the mass of potassium chlorate required to liberate oxygen. That means I am going to be dissociating. I'll say that the required equation is going to be KClO3 has to liberate, calculate the amount of potassium chlorate required to liberate oxygen. Okay. Now if it liberates oxygen, if potassium chlorate liberates oxygen, what will remain? You will have potassium chloride remaining. From potassium chlorate, if oxygen is given out, then what will remain is potassium chloride. Now let's balance the equation. Guys, oxygen is 3 over here, oxygen is 2 over here. Hence, you will multiply this by 2, you will multiply this by 3. As a result, your oxygen is balanced. To balance your KCl, you will put 2 here, right? Oxygen is your gas, right? That means I require 2 molecules of potassium chlorate to liberate 3 molecules of oxygen. I require 2 molecules of potassium chlorate. There are 2 molecules, guys, here of potassium chlorate, which are liberating 3 molecules of oxygen, right? Now, 2 molecules of potassium chlorate. They've given you that the molar mass of potassium chlorate. So, molar mass of potassium chlorate is 2 into 1 is given to you as 112.5 mass of potassium chlorate required. is going to be 2 into 112.5, which is nothing but 225 grams. So 225 grams of potassium chlorate will liberate mass of oxygen liberated. 3 moles are liberated, and they've given you that the molar mass you require molar mass of oxygen. You are supposed to know that 1 mole of any substance occupies 22.4 decimeter cube. That means if 3 moles are liberated, how much space will they occupy? They will occupy, say, about 67.2 decimeter cube. This won't be mass, this will be the volume of oxygen liberated, is 67.2 decimeter cube. That means 225 grams of potassium chlorate liberates 67.2 decimeter cube of oxygen. How much oxygen do I require? They are saying that, let us assume that X grams of potassium chlorate liberate, you want 6.72 decimeter cube of oxygen. Very simple. If 225 grams is liberating 67.2 decimeter cube, then X will be nothing but 6.72 into 225 divided by 67.2. So that is going to be nothing but 22.5 grams. So 22.5 grams of potassium chlorate will liberate the requisite oxygen. Next, take on next one, please. Take on next one, please. Calculate the volume of oxygen required. Calculate the volume of oxygen required for complete combustion of 0.25 moles, complete combustion of 0.25 moles of methane, 0.25 moles of methane at STP. I want complete combustion of methane. Methane is CH4. Combustion means I'm going to burn it in air. When any organic compound is burned in air, you get carbon dioxide gas and water, right? Let's balance the equation, guys. Oxygen is 2 and 1 3, make this as 4. So hydrogen also gets balanced, put 2 here. That means 1 mole of methane, look at this, the number is 1 here, is burned by 2 moles of oxygen. 1 mole, guys, see this, 1 mole of methane is burned by 2 moles of oxygen. They have said that calculate the volume of oxygen required. That means I can say that 1 mole of methane requires 2 moles of oxygen for combustion, right? In which case 2 moles of oxygen, that means 1 mole of any substance occupies 22.4 decimeter cube, right? That means I can say 1 mole of methane requires 2 moles of oxygen, which is equal to 2 into 22.4, that is 44.8 decimeter cube of oxygen. Now they've asked you that if you have 0.25 moles, then what is the volume of oxygen required? Therefore, for 0.25 moles of methane, X decimeter cube of oxygen is required. X decimeter cube means X will be equal to 0.25 into 44.8, multiply this, you will get your answer, right, which will be say about 11.2 decimeter cube. So if you supply it with 11.2 decimeter cube of oxygen, entire methane will be burned, right. Next, take on next one please. Calculate the volume of hydrogen. Next sum. Calculate the volume of hydrogen required for complete combustion. Calculate the volume of hydrogen required for complete combustion. Of 0.25 decimeter cube. 0.25 decimeter cube of ethyne. 0.25 decimeter cube of ethyne. Right? Let's see the required equation. I want combustion of ethyne by any ethyne. This is my ethyne. I want to burn it in air. When any organic compound is burnt in air, you get carbon dioxide and water. Balance the equation. Guys, the equation, no, they don't want combustion, sorry, they want hydrogenation. Did I say combustion? Just make, calculate the volume of hydrogen required for complete hydrogenation. Just make that correction, guys. Hydrogenation. That means I'm reacting with hydrogen. If I require ethyne with hydrogen, guys, addition reaction will take place. The two reactants will combine together to give you a single product, C2H6. They will give you ethyne. Again, they give you C2H4. They will give you ethane. Okay. Balance the reaction. If I balance the reaction, 4. So I'll have to put 2 here. That means 1 mole of ethyne requires 2 moles of hydrogen. 1 mole of, first you make the equation, whatever is the balancing is the number of moles. 1 mole of ethyne requires 2 moles of hydrogen. Now we know that 1 mole of ethyne will occupy 22.4 decimeter cube of space, and 2 moles of hydrogen will occupy 2 into 22.4, that is 44.8 decimeter cube space. This is the volume that is going to be occupied. That means 22.4 decimeter cube of ethyne is hydrogenated, or is hydrogenated by 44.8 decimeter cube of hydrogen. 22, guys, see this, 22.4 decimeter cube of ethyne requires 44.8 decimeter cube of hydrogen. They are saying that calculate the volume of hydrogen required for 0.25 decimeter cube of ethyne gas. I have only 0.25 decimeter cube of ethyne gas. So how much hydrogen do I require? Cross multiply. When you cross multiply that, you get your answer. So your answer is going to be, guys, x is equal to 0.25 into 44.8 divided by 22.4. Multiply that, you should get the answer. Fine. I'm not doing that multiplication. At least this much you can do on your own. Take down next one, please. Calculate the number of atoms. Calculate the number of atoms of hydrogen. Calculate the number of atoms of hydrogen present. Calculate the number of atoms of hydrogen present in 5.6 grams of urea. Present in 5.6 grams of urea. If the molar mass of urea if the molar mass of urea is 60 grams per mole, is 60 grams per mole, also calculate the number of nitrogen, carbon and oxygen atoms. Also calculate the number of nitrogen, carbon and oxygen atom. Now guys, let's see this. Molecular formula of urea is nothing but CONH2 twice. That's my molecular formula of urea. Now if that is the molecular formula of urea, that means one molecule of urea has one carbon atom, it has one oxygen atom, it has two nitrogen atoms and four hydrogen atoms. All these are present in 60 grams of urea. How do I know 60 grams? Because they give you 1 mole of urea, the molar mass is 60 grams, and 1 mole of urea is 60 grams, right? So in that case, the number of hydrogen atoms present. Now let's see this. 60 grams of urea has 4 hydrogen atoms, right? Now one atom of a substance they've given you calculate the number of hydrogen atoms present in 5.6 grams of urea. 5.6 grams of urea, right? The number of hydrogen atoms present is 4, right? 1 mole of any substance has 6.022 into 10 raised to 23 particles. 6.022 into 10 raised to 23 divided by the total mass, that 1 molar mass of urea. So guys, when you want to find out the number of atoms, there is 5.6 grams of urea, there are 4 atoms in one molecule. To convert it into, from grams to the number of atoms, you are multiplying by the conversion factor, which is your Avogadro's number, 6.022 into 10 raised to 23, and you are dividing by the molar mass. So when you calculate this, you will come to the number of hydrogen atoms. Now once you know the method, you can find out anything. Number of, what else have they asked you to find out? Nitrogen atoms. Number of nitrogen atoms, same way. You have 5.6 grams of urea. How many nitrogen atoms are there? 2. To convert from grams to number of atom, conversion factor, Avogadro's number, divided by the molar mass, 60. Then I'm not doing the calculation, I'm leaving the calculation for you all to do. Number of carbon atoms. You have 5.6 grams of urea, you have 1 carbon atom. To convert from grams to atoms, you multiply by Avogadro's number and divide by the molar mass. Similarly, number of oxygen atoms, you have 5.6 grams of urea, there is 1 oxygen atom. Convert from grams to number of atoms, conversion factor, Avogadro's number divided by the molar mass. That's how you can find out the number of atoms in a particular weight of a molecule. Fine, do we get this in here? Take down another sum, guys. Calculate the number of carbon, hydrogen and oxygen atom. calculate the number of carbon, hydrogen and oxygen atom. Calculate the number of carbon, hydrogen and oxygen atoms in 72.5 grams in 72.5 grams of 72.5 grams of isopropanol. Whose molar mass is 60. Whose molar mass is 60. Right, guys, replica of the previous sum. In fact, I have also written the molecular formula of isopropanol. So you should be able to solve this sum, guys. It is a replica of the previous sum. It has 3 carbon atoms, 8 hydrogen atoms, 1 oxygen atom. They've given you the molar mass. They've also said that you have 72.5 grams. So you should be able to do this. I'm leaving this sum for you all to solve on your own. Next, take up next sum, guys. I'm leaving this sum for you all to solve on your own. Look at the previous sum and solve this sum. Phosphoric acid for phosphoric acid, calculate the mass percentage for phosphoric acid. Calculate the mass percentage composition of. Calculate the mass percentage composition of hydrogen, phosphorus and oxygen if the atomic mass of hydrogen is 1, phosphorus is 31 and oxygen is 16. If the atomic mass of hydrogen is 1, phosphorus is 31 and oxygen is 16. Now guys, I have to find out the percentage composition of different elements. First of all, what is the molecular formula of phosphoric acid? The molecular formula of phosphoric acid is H3PO4. Right? Once you have this, then you can find out the molar mass of phosphoric acid. How do I find out the molar mass? You have 3 atoms of hydrogen. Each atom of hydrogen is 1. You have 1 atom of phosphorus. You have 4 atoms of oxygen. When you solve this, you should get this as 98 grams per mole. That's my molar mass. Once you have the molar mass, then you can find out the percentage composition. So percentage of hydrogen. Guys, look at this. There are 3 atoms of hydrogen, each is 1, divided by total into 100. Simple, straightforward. Similarly, you can find out percentage of phosphorus. Phosphorus, there was 1 molecule of phosphorus, so 31 divided by total into 100. Similarly, percentage of oxygen. 16 fours are 64. 1 is 16, there are 4 atoms, divided by 98 into 100. You can do your calculation and get the answer. That will give you the percentage composition of hydrogen, phosphorus and oxygen in phosphoric acid. Fine. Take down next one, please. Calculate the percentage composition. Next, calculate the percentage composition of nitric acid. Calculate the percentage composition of nitric acid. calculate the percentage composition of nitric acid if H is 1, N is 14 and O is 16. H is 1, N is 14 and O is 16. Right? Nitric acid, guys, we know is HNO3. If you look at the previous sum, you should be able to do it. It's replica of the previous sum. I'm not solving it. I want you to practice this sum on your own. Solve this on your own. Right? Take down next sum, please. Vitamin C contains 11 sum I'm not doing, so I'm doing the 12 sum right now. Vitamin C contains 40.92% of carbon, 40.92% of carbon, 4.58% of hydrogen and 54.5% of oxygen. Calculate the empirical formula. Calculate the empirical formula. Calculate the empirical formula of vitamin C. Calculate the empirical formula of vitamin C. Now guys, moles of carbon. How many moles of carbon will be present? When you want to convert percentage into moles, how do you do that? It is percentage divided by atomic mass. When you want to convert percentage into moles, how do you do that? It is percentage divided by atomic mass. So for carbon it will be 40.92 divided by the atomic mass of carbon. Atomic mass of carbon is 12. When you divide this is 3.41. Similarly, you can find out moles of hydrogen. Percentage is 4.58 divided by hydrogen is 1. So that's 4.58. Then you can find out moles of oxygen. Oxygen is 54.5 divided by 16, which is going to be 3.41 approximately. Right? Therefore, what will be the ratio of number of moles of carbon, hydrogen and oxygen? Guys, how do I find this out? I have three ratios, 3.41, 4.58 and 3.41. Divide, see, I have three ratios, 3.41, 4.58 and 3.41. Divide all the three ratios by the smallest number that you have. Here, two numbers are same. Otherwise, out of the three numbers, whichever is the smallest number, you divide by the smallest number. That means you will divide by 3.41, 3.41, 3.41. You are going to divide all the three numbers by 3.41. In which case, you will get this ratio as 1:1.34:1. Right? Now, I want to convert the ratio into a whole number. 1.34. What should I multiply 1.34 so that I get a whole number? I don't want a decimal number. Right? The closest number that will be possible without a decimal is by multiplying by 3. If I multiply this by 3, I will get 3 is to 4 3s are 12, 3 3s are 9 and 10. 4.02 is to 3. 4.02 is approximately equal to 4. So 3 is to 4 is to 3. Therefore, the empirical formula now, what were the three elements you have taken? Carbon, hydrogen and oxygen. The ratio is 3, 4 and 3. So you will write this as 3, 4 and 3. So the empirical formula for vitamin C will be C3H4O3. Right? Take down next one please. An inorganic compound contains 24.75% of potassium, 24.75% of potassium and 34.75% of magnesium. 34.75% of magnesium and some other element. Find the empirical formula of the compound. Find the empirical formula of the compound if K is 39, Mn is 59 and oxygen is 16. Right? Replica of the previous sum. The only thing is they are saying that some other element. Now remember, whenever they say some other element, that other element always has to be oxygen. And how will I find out percentage of oxygen? Percentage of oxygen will be 100 by 100 because the total percentage is always 100 minus the percentage of potassium and magnesium. So 24.75 plus 34.75. That will give you the percentage of oxygen. Once you have the percentage of oxygen, it becomes like the previous sum. You have percentage, you have to find out empirical formula. You should be able to find this, right? The answer for this should be, when you solve this, you should get this as K1 Mn1O4. That should be your empirical formula when you solve it, right? Take down the last sum to finish this chapter, guys. Phosphoric acid contains 3.086% of hydrogen, 31.61% of phosphorus, 31.61% of phosphorus and some other element. If H is equal to 1.01, P is equal to 31 and O is equal to 16, find the empirical formula. Also, if the molar mass of phosphoric acid is 98.03, if the molar mass of phosphoric acid is 98.03, find the molecular formula. Find the molecular formula of phosphoric acid. Now guys, I have already taught you how to calculate the empirical formula. I am not showing you that part again. Right? When you solve this, let's assume that you get the empirical formula. You know how to solve the empirical formula. Percentage is given, the other element is oxygen. You should be able to get the empirical formula. Let's assume that you get the empirical formula as H3PO4. Once you get the empirical formula, guys, in order to find out molecular formula, first find out the empirical formula weight. empirical formula weight is 1 into 3 plus phosphorus is 31 plus 4 into 16, right? When you solve this, you will get your empirical formula weight as say 98.03, right? Now, number of moles N is given by the formula molar mass divided by empirical formula weight. The molar mass given to you in the sum, guys, is 98.03. Empirical formula weight you found out as 98.03, which is going to be equal to 1. Molecular formula is given by the formula N into empirical formula. So 1 into empirical formula. Empirical formula is H3PO4. So this will be H3PO4. Guys, just in case, I just want to show you this. Just in case, if N was 2, then how would the answer be? It would have been 2 into H3PO4, which would have been H6P2O8. So if it's a number other than 1, whatever is the number, you will multiply it by that ratios, right? Do we get this thing clear? This finishes all the numericals of this chapter. We'll stop this here for the day. Thank you very much.